In computer networks, we are looking at chapter number 1, Introduction. Reference models. So in a network design, the layered protocol design, that is different layers, different functions, different services, different protocols, this is a key concept. Because if any work has complexity, it is better to divide it properly so that we can handle it. And also, what is the functionality of each layer and what is the interaction between them? For example, what transport layer is going to provide to session? So what session and session layer are going to share? What will be the protocol shared? So there are two important models, TCPIP reference model and the OSI reference model. These models give you an idea that what kind of services protocols need to be used, what is the work of each layer, and how as a network designer you can implement it. The ISO OSI reference model. Now this OSI model, first let me tell you that this ISO OSI has come as a standardization, that is Open System Interconnection. This is the name of the model, and this was proposed by International Standards Organization ISO, because at that time there were so many protocols, so many things happening. It was important to standardize it so that everyone can use it in a proper way, in a arranged and managed way. This was in 1983. In 1995 it was revised, and as I said, it was called as ISO OSI. ISO means International Standards Organization and OSI is for Open Systems Interconnection. Open Systems Interconnection. And this was open, called open, because there were various networks which wanted to be connected to other networks. So this, for example, two networks are here, N1 N2. They are open for the communication with other systems. So this OSI is what they should follow, these different networks. So OSI model has 7 layers. 7 layers. Now you may ask why these are 7, why they are not 6. I'll answer this. But the first layer, the topmost, is application layer. Whenever you are working on your computer or laptop, the first screen comes for any networking, that is a user interface. So application layer is providing you a user interface. Presentation is all about whatever data, information you are handling, how to present it, and even it deals with the encryption and decryption. That is, you don't want any eavesdropper or any kind of threat. So in order to handle that, presentation layer is responsible. Session layer, as the name suggests, for session. So you have this maintains distinction between data of separate application. If you are using two separate applications, how to maintain the distinction of data used by one and another. And it also provides dialogue control between the host. Host is nothing but the computers, different computers in the communication. This application, presentation and session, all these 3 layers have been combined in the TCPIP layer, because all the work it is doing is for user interaction. And then we have the transport layer. Transport layer is to provide the end-to-end connection. It can be reliable, it can be unreliable. So we have TCP and UDP in the another TCPIP conceptual layer. But here it is also dealing with the flow control, transport layer. Network layer, it provides the logical addressing, not the actual addressing or physical addressing. Please understand, this provides path determination using the logical addressing, not the actual addressing in the ISO OSI layer. And then we have to convert this, because every address is physical address, like the MAC address, like the IP address. So the data link layer does this thing, provides media access and physical addressing. So there is a combination of physical and the network, that is the logical addressing. Physical layer is all about transferring the data. So you are sending the bit stream, etc. So it converts digital data so that it can be sent over the physical medium. And this moves data between the different computers, hosts, or the nodes in the network. So the data starts from here, from application. Every layer adds something, and finally through physical layer, actual wires, it can be fiber optic, it can be coaxial cable. Then it goes to the other system, and there also we have a protocol stack. So it starts from the lower layer, first layer, and it goes up to the 7th layer. Now the question is, why these are 7 layers? What layers are doing? Why we have just 7? Why we are not having 6? Why we are not having 5? Why we are not having 100? So there are certain principles for these layers, why they were defined by ISO. So this ISO has certain principles. So the first principle is a layer created wherever different abstraction is needed. Abstraction means if you want to more exemplify it, the work of a layer, then layer is created. Each layer should perform a well-defined function. Every layer, the function of each layer has to conform, has to follow the internationally standardized protocols. And the layer boundaries is chosen such that the information flow between the interfaces. Interfaces is what? Between two layers there is interfacing. So the layer boundary is chosen such that the information flow is minimum. Then the layer decided should be not bulging or should not be thin. That is, the number of layers should be large and small enough that various function can be accommodated. One should not be overwhelmed, one should not have less function. So in OSI layer, 3 important concepts are there: services, interfaces, and protocol. Services are all the primitives or operation or function. The lower level will give it to the upper layer. Interface is the layer, or you can say a virtual concept between two layers that you can change anytime without changing if new technology comes. So no need to change the layer content, but just change the interfacing content if new technology, new protocols come. And protocols means two peers, that is two equal layers, they have decided upon certain rules, convention or regulation. For example, what will be the message size? What will be the header added? All these are protocols or agreed upon content before the conversation could commence. The TCPIP reference model. TCPIP is Transmission Control Protocol, Internet Protocol. Now this TCPIP was not a model earlier. It was actually the protocols which was used in the grandparent of all wide area network, ARPANET. You know, ARPANET came, then the NSF net came, then the ANS net came, and now we have the internet. So the grandparents, you can call it, they were also using this. So ARPANET was a research network. It was sponsored by Department of Defense, and they have connected all the major universities, government installation, and they were using PSTN, that is the leased telephone lines. Now the major idea was what? That if anything breaks in between, still the communication should commence. So when this satellite and radio communications or radio networks were also added to this underlying backbone, there was a problem in the protocols. So at that time the TCP/IP was not being used. Initially it was all different kind of protocols being used. But when different satellite radio network came in, then the TCP/IP came. So there was a new reference architecture was developed, TCP/IP reference model. And this TCP/IP reference model has come from two primary protocols that were used in earlier internet, that is the Transmission Control Protocol and Internet Protocol. These two are different protocols being used, and they were so popular because of these two primary protocols. The reference model was named as TCP/IP reference model, right? So this TCP/IP came as a standardization of other protocols which were going on the internet. So it was first described by Cerf and Khan, and then it was refined and defined as a standard by Braden, and the design philosophy of this reference model was given by Clark. Now, requirement of DoD, because we are discussing the first layer now, that is the data link layer. We also call it as a link layer. That is the lowermost layer of TCP/IP reference model. TCP/IP has 4 layers, because in the ISO OSI there were 7 layers, and the 3 uppermost layer, application, session and presentation, they were combined into 1 layer, application. So how if you compute it, it will be 4 layers, because 3 layers have been combined. But there is some discussion for the lowermost layer here. I hope you got the idea. 7 layers ISO OSI reference model. TCP/IP has 4, because 3 of the uppermost layer of ISO OSI has been combined. Now the Department of Defense has a specific requirement that if there is any connection, if intermediate connection is broken, then still the communication should take place. So this is the requirement of Department of Defense, that is US. This has led to packet switching network, and this is based on connectionless layer. That is, if something breaks, the packet should find another way so that it reaches, the communication still take place. So there were Paul Barron, there were other people, Larry Roberts, all were involved at that time. And because of this connectionless layer, the lowest layer here, the link layer in the TCP/IP, this describes what links means serial lines. It can be classic internet. So link layer is only defining or describing what these lines or Ethernet should do in order to meet the concept of connectionless internet layer, right? So in all, if you say this link layer is not actually a layer, it is an interface between the host or the computer and the lower transmission links, which are the actual cables through which the data will flow. I hope you got the idea. This is also the criticism of TCP/IP, that link layer is actually not a layer. It is just an interface between host and transmission links, because it is just describing how this serial line and classic Ethernet should do what they should do in order to to conform to the concept of connectionless internet layer. Coming to the second layer, that is the internet layer. This internet layer, the work and the job of internet layer is to deliver the IP, Internet Protocol IP packets, where they are supposed to go to the destination. Now, in order to understand this, just think about an analogy with the snail or mail system. A person does what? He has, say, number of international letters he wants to send internationally. So he's just dropping all these letters into a mailbox in his country. Now, most of these letters and all of the letters, for example, from Canada, now he wants to send it to India. All these letters, all of them, or one or two may not be going to the destination, otherwise all will be delivered. So now what I'm trying to suggest here is the letter are going through various international mail gateways. You never know. Not the sender, neither the receiver. They are not aware. These letters are going through international mail gateways. And each country, that is in this case each network, they have their own say stamps, envelope size, delivery rules. This is all also hidden from the users. So this internet layer is actually defining the official packet format. Packet is nothing but the combination of bits only, along with some headers, some ancillary information to support, and protocol called IP protocol. So this IP, along with this IP, there is one more companion protocol which helps IP to function, which is called the ICMP, that is Internet Control Message Protocol. Okay, this is all about messaging. Then in the TCP/IP reference model, we have the transport layer. If you see here, there are two major boxes, TCP and UDP. So transport layer allows the peer entities on the source and the destination host to carry out actual conversation. So in order to have a conversation, the two end-to-end protocols, transport protocols, have been defined in this transport layer of TCP/IP reference model. Because this is all about the actual conversation between the peers, that is for transport layer or application layer. So TCP and UDP, transmission control protocol, and there is another one which is called as UDP, that is the user datagram protocol. So what is the difference? TCP is a reliable connection oriented protocol. That is, when you are using TCP, you have to establish a proper connection. Only then the byte stream can be sent and can be received. So this one machine till another machine, there has to be a connection. That is why we are calling it reliable. Reliable because every time you are getting the acknowledgement. That is, this is the bit stream I am talking about. For example, 10110111. So how to divide it? So it segments the incoming byte stream into discrete messages, and then it passes this to the lower layer, which is the internet layer. So this byte stream has to be divided into discrete messages also. So this is dividing and sending, that is disassembling. But at the peer, that is different machine, same peer at destination, the receiving TCP processes, what does they do? They reassemble the receiving message into the output stream. So these two messages have been combined. This one message, the last bit has to go with another packet, right? So TCP also handles the flow control. What is swamping? Say one machine is sending faster than the other machine receiving. So the other machine will get flooded, overwhelmed. It will get swarmed. The TCP also handles the flow control. Coming to the UDP, user datagram protocol, it's just the reverse of TCP because it is unreliable. Unreliable is not a bad word here. Unreliable is only that you are not getting acknowledgements every time. See, so the UDP is connectionless protocol because the data or the messages or the packet they are going through which path the network will configure and decide. There will be no proper connection being established and no reliability, that is, no acknowledgements will come. Because the problem in TCP is that there is some sequencing, flow control, that is the number of ACK will come. So there will be overhead, there will be unnecessary delay. Sometimes user wouldn't like this. So a user who wants a prompt delivery, the accuracy is not that important. For example, speech and video, some one tin sound or video, one frame or one say pixel goes, it will not matter. But you need a timely delivery. For that we'll use UDP. In the TCP/IP reference model, the topmost layer is the application layer. The TCP/IP, please note that it doesn't have a session or a presentation layers. These all three layers have actually been combined. Application layer, where a user actually works. It's all about user interface and the data, how data will be presented. The application layer contains all the higher level protocols. Initially, there were some protocols, then other protocols were added. For example, initially we had Telnet, virtual terminal, file transfer protocol, FTP, and then we have electronic mail, simple mail transfer protocol. Various other protocols were added. For example, DNS, domain name system. This is for mapping the names of the host of the computer with their network addresses. That is the MAC, IP, etc. So this is DNS were added. And then we have a very popular HTTP. When Tim Berners-Lee, he created the www, World Wide Web actually, then the HTTP was introduced. And then RTP and RTCP, the protocol for delivering real-time media for voice and movies. Those who will be dealing with voice and movies, they have to learn about this RTP. So this is what the situation is. The ISO OSI layer has certain criticism. The criticism, we can divide it into the bad timing, the bad design, the bad implementation, even the bad politics. So bad timing here means the ISO OSI layer, when it came, the TCPIP was already popular. The industry and the research people, this ISO OSI protocol reference model, it got struck, it was crushed. So the industry and research and also TCPIP was already popular. So timing was bad. Then the bad technology. See, what is the criticism with respect to bad technology? This OSI model, because the protocols and the definition being given by these ISO actually, it was quite complex. It was very difficult to implement, and the operation was, even if it it is very inefficient. And most of the functions like they're repeating, like addressing, flow control, error control, they are in different layers. They are reappearing again and again. Bad implementation. That is, as I said, it was complex. And the initial implementation, when it came, it was very difficult. It was very huge. Even the performance issue, it was slow, unwidely. And if you compare TCP/IP, this implementation was easy. So people just took it with no time. There was politics also involved. See, the TCP/IP and Unix were loved by the academia, that is the university people, the research people. And the ISO OSI 7 layer, people thought, or it was being fed, that this has come from Europe. And the government of USA is trying to pressurize or put this on the head of the users here. That is why TCP/IP became popular, and then this bad politics happened. The criticism of TCP/IP, because TCP/IP is not a perfect protocol stack, or you can say reference model. First of all, ISO OSI has clear distinction, and the key concept is service, interface, and protocol. But in this TCP/IP reference model, these three were not even, they are not defined clearly, which are the backbone of any network design. And all these, all the concept cannot be proven here. For example, if you take Bluetooth, you cannot define Bluetooth protocol stack with reference to TCP/IP. And the idea of the lower layer, physical or data link or network interface, host to host, many names are there. Host to network. This layer is not there. There is no physical distinction between physical and data link layer. Actually, this layer is just an interface. It just guides the links that what you have to do. That is nothing substantial this layer does. And then the TCP/IP in IP and TCP. This TCP/IP, these were two protocols, and they were well thought, well discussed. Everything was very proper about them. But what about the other protocols? They were just made, they were ad hoc. And these ad hoc protocols are still there in TCP/IP. This was the greatest criticism. That is, you cannot have just TCP/IP. What about other protocols in order for a network to work? In telecommunication world, there is standardization. That is who in the telecommunication world. What are the international standards? What with respect to internet standards world? So there has to be some companies or authorities who will define and people will follow. So the topmost in the telecommunication world is ITU, International Telecommunication Union. So it has all flavor. ITU T is what we are interested in. So previously it was only in the United States. Now it is the United Nations standard. And this is telecommunication. Now coming to other international standards, we have ISO, that is International Organization for Standardization, ANSI, NIST, IEEE, I'll just show you. Then we're coming to the internet standards. We have Internet Architecture Board, IAB. Then we have the RFC, which is the request for comments, IRTF, Internet Research Task Force, IETF, Internet Engineering Task Force. So these are different authorities, standardizing authorities, working authorities. I'll just take an example of IEEE. How does it work actually? So how does it work? If you are talking about, say, Ethernet, then 802.3 is dealing with Ethernet. Wi-Fi 802.11 is going to handle. For example, WiMAX, it was there, but it flopped. So it is not there. 802.16 is not functional now. There are giant names in telecommunication world, the authorities, the organization. So first is International Telecommunication Union. In 1865 it was founded, and now it is a specialized agency of United Nations. Not only United States, it's UN. So the telecom standardization sector, ITU-T. So it is developing a lot of standards for telecommunication industry. Then we have in 1947 the ISO, International Organization for Standardization. Please see that the acronym is IOS, but it is not spoken like this. It is spoken as International Standard of International Organization for Standard, not International Standard Organization, right? So this makes industrial standards, even the management standards. In 1906, the International Electrotechnical Commission, it publishes standards for the electrical and electronic industries. Then we have ISO IEC Joint Technical Committee. This is for IT standards. What are the metric units in the computer memory and the communication? What is the confusion? How are we going to deal with this? So capital B is for bytes, small b is for bits. In your hard drive, in your SSD, in your pen drive, when the data is stored, we talk in the power of 2. Power 2 is what? See, 2 to the power 10, this is the basic unit, that is 1024. So this is a kilobyte. A is capital B is capital. So kilobyte. So 1024 byte is 1 kilobyte. 1 byte is 8 bit. Now if you increase it, that is 2 to the power 20. That is 1024 into 1024. How much this becomes? This is 1024 into 1024 is going to be 1048576 bytes. But what it will be? It will be 1 MB. 1 KB is not 10 to the power 3 bytes here. 1 KB is 1024 byte. And 1 MB is 1048576 byte. It is not 10 to the power 6 bytes in terms of storage of computer. Okay, 1 byte is, as I said, it is 8 bit. So capital B will be used for bytes, and we are talking about the memory, the storage, the computer science. Now when it comes to the network or communication, we will talk about the data rate. So data rate, this small b will come. That is, small b is for bits. Okay. So it is not the power of 2 to the power something, but it is actually 10 to the power something. The power of 10 in computer networking speed, it is not power of 2. For example, 10 to the power 3 is 1000. And this 1000 is 1 kilobit per second. BPS is small here. Then 10 to the power 6, that is 100 into 100, that is 10 to the power 6, that is 1 megabits per second. BPS is small. Here we are talking about bits per second. Okay. Storage, we take 2 to the power 10, that is 1024 is equivalent to 1000 there. And in networking, it's 10 to the power, not power of 2. Okay. So this is the idea. You can take milli, and this kilo is 10 to the power 3, and then we have this kilobyte KB, and this is 1000 bytes. This megabytes. Then we have gigabyte, terabyte, petabyte, exabyte, zettabyte, and the yottabyte. Okay, this is all about the discussion of computer networks. Thank you so much. Take care of yourself.